Hello, this is Bruce again, and today we're going to look at how to print out values of numbers from your program. It's always useful to be able to read data into a program and to print information back out again. This is both if you want to know the value of something you've calculated. It's also useful for debugging. C and C++ and the Arduino each does this in a different way, unfortunately. And we will start out using the Arduino way for now because that's very common. We'll use a programming object called serial to do this. Serial has to appear in at least two places. First, it has to appear in setup, and second, it has to appear where the printing is actually going to occur. It's spelled with a capital S. This is important. Let's write in a program now, for example, and we'll print out the value of a variable we'll call A with the following program. So I have started up the Arduino over on my right side of my screen, move the cursor around for a moment, and I've got the usual void setup and void loop with nothing in them. And I'm going to go to void setup. I'm going to bring it down a little bit, put in a comment here, and say, test serial printing. And I guess my name, Bruce Hubbard, and we'll put in a year 2014 and a month, it's 10, and we'll just check on the day, and it is now October 8th, 08, version 1.0. All right. First thing we're going to do is put in our global variable, whose name is A. GLOBAL variable, ES. Okay, it's an integer, its name is A, and its initial value is 0, semicolon. Put in a space, just because it looks good, isn't needed. Okay, void setup. Put your setup code in here to run once. There is one important thing we need to do, and we need to type in, if you look over on the left under number 3, you need to say capital S-E-R-I-A-L, serial dot begin. Dot and a lowercase b on the begin, and it's all run together, no spaces. Now we can put in a space if we want, open parentheses, 9600, 00, close parentheses, semicolon. That's all we need to do in order to get serial IO, as I guess you would technically call it, going to our serial print window. So what are the parts of this? We'll talk about them more in detail later. But essentially, we're telling the Arduino and the laptop that we want to send bits back and forth at about 9600 per second. They're actually bauds, and we will talk about bauds in a little bit. So my comment here is initialize global variable. We should have said that up here so that my code here that I'm typing in follows what you see over on the left. Initialize global variable A to 0. Global variable A to 0. And remember, a global variable is available everywhere in the program. Its value never vanishes, and if we change it, it remains changed. Okay, so down here in the setup, what we're going to do is we're going to initialize what's called serial communication to 9600 baud. So we'll return in a little bit and talk about what a baud is in more detail. Down here inside loop, we're going to put in our program. And I'll give it 2 spaces. And we're going to say serial, S-E-R-I-A-L, dot, this time print line. That's the way I say it. P serial dot P-R-I-N-T-L-N. And it turns red. And we're going to open parentheses, and we're going to put the name of the variable A in there. Close parentheses, semicolon. Print A, we'll say variable. I'm going to say global because of a change I'm going to make in a minute. G-L-O-B-A-L, variable A to the serial window. All right. This is going to print the value of A out once per line. That's what print line means. I can also print things out so that they run across the line horizontally like this. That will be a different command we'll see in a minute. Okay, so what am I going to do next? I'm going to add 1 to A. A equals A plus 1, semicolon. And now this is going to run very fast, space. If I run this program the way I've written it, and I won't be able to really see the value of A, it's going to stream past. In fact, I'll do that before I add something else. So let's go up to the top here. Let's go up to the Arduino Tools menu. Let's check the board. Our board is an Uno. Let's check the port. Nothing is checked, but the TTY USB modem is there, which means my Arduino is plugged in and functioning. I'll click it. All right. And then I'm going to do a test compile perhaps first to make sure that I have no errors. It says done compiling down here at the bottom. Go back up to the top. Click the horizontal arrow, which means send my code to my Arduino. And it says down here that it is uploading, done uploading, and my Arduino is running silently. Okay, that's not quite the case. See over here on the right, when I go over this little magnifying glass, it says serial monitor. Click on that dude once, and you will see a window, which I will shrink down a little bit here so it's not quite so huge. And we can sort of get it to fit below our program, all the way below our program. And you can see those numbers streaming by, a million a second, well, not a million, but about 1,000, perhaps a second. And, well, not quite that, 4,001, 4,002, 4,003, about 100 a second. Way too fast to see anything. So I'm going to close this window, and I'm going to slow it down. And so what I'm going to do is I'm going to add an artificial delay, D-E-L-A-Y. And I like numbers somewhere in and around 1 or 2/10 of a second for watching what is happening. So I'm going to add that delay in there. I'm going to go back up to the top to the horizontal arrow. You can see over here on the left, delay 200, close curly brace, under 3, last point. Delay output slightly. Okay, so let's keep up with our comments. What does A say? A says increase A by 1. Okay, and then delay 100 says, well, it says delay output slightly. D-E-L-A-Y, 0.2 second is what that really is for readability. Okay, so let's see what happened. Let's go back up to the top. Let's press the horizontal arrow. Let's take a look at the upload, done uploading down here at the bottom. Let's go over here again to the serial monitor in the upper right. Click on that. Our window has now opened. It remembers where we were. You see it started over again. You see it started at 1. It was at a funny number. And now they're ticking, these things are ticking along at about 5 a second. And it's much easier to see what's going on. We are not getting as far as fast, but we're doing okay. Look down here. It says auto scroll. If I turn it off, this stops moving. But this little scroll bar over here on the right keeps ticking upwards. If I go back up and turn on auto scroll, watch it, it says 104, jumps forward to 160. It's been collecting numbers. Over here is a little marker, or a little control that says 9600 baud. You can see I can range it from 300 to 115, 200. That's really very slow to very fast. We'll leave it at 9600, or our program won't be able to talk. And you see that every time we update anything with the serial window, it starts all our code over again. Okay, so let's close the serial window. Good stuff. All right, the next thing that we're going to do, we'll go over here and we'll check, make sure we've done everything. Over on the left, watch the numbers increase. Great. Okay, so it now says add a local variable B and print it out. Okay, so what's a local variable? I'm over here by void loop. A local variable is contained within a pair of curly braces. You see that the A up on top is not inside anything. That's what makes it global. If I go down here to void loop and I create a variable B, and I say that by int B equals 0, I've created a local variable. It comes into existence with the open curly brace of loop. It exists inside, and it ceases to exist when I hit the closed curly brace, and it goes back into available free memory. It's called a local or sometimes an automatic variable because it's created and destroyed automatically as these braces occur and end. Okay, so let's look at its value. Not only do we want to create it, so if we look at the program over here on the left by 5, I'm going to be typing that in. All right, so over on the right, serial print line. I'm going to change that to a serial print, turns red again, it's happy. Now, I'd like to print out a B as well, so I'm going to say serial dot print. Now, I need to say print line, or I will get all the A's and B's stuck together. I can do that for you if you'd like. Okay, here's B. We'll just do a pair of serial prints, A and B. All right, and we'll see what we get. Upload. Done uploading. Over to the serial window. Open the serial window, and you can see that horizontally across the screen there's a whole bunch of numbers, and they're just continuing on one line. Kind of hard to read. Okay, so we want a space between them. So the first one says serial print A. In between those two, I'm going to say capital SERIAL dot print, INT. Open the parentheses, and I want to print out a space. Spaces are alphabetic characters. They're not considered to be numbers normally. And you get that by typing a double quote, that's shift, single quote, space bar, double quote, close parentheses, semicolon. Print a space. Add space. Okay, so now I've got a space between A and B, and if we run this, upload up there at the top, go back over to the right, take a look at my serial window. I've got spaces, okay, but I've still also got them all on the same line. So I have one more thing I need to fix. I meant to just close that window. Serial print the value of A, serial print a space, serial print the value of B, and I need to attach the LN suffix to that one, print line, so that I get a new line. All right, what's my comment here? Print local variable. Okay, let me go up and fix that B to be a V. Local variable B. All right, print A, print a space, print B, and add a new line, which is a invisible character that causes the output to jump from one line to the next, is what that means. All right, let's give this a try. Up here at the horizontal arrow, I'm hoping I didn't make any mistakes. It's uploading. Done uploading. Go over to the right to the serial monitor. Open the serial monitor, and there we go. It restarts at 0. The first one is A. It's counting up nicely. But look at the second one, B. It's a 0. Well, that's kind of understandable. I didn't increase it by anything. Let's add one to B. B equals B plus 1, semicolon. All right, now we're adding one to A and to B. Let's go take a look. Uploading. Done uploading. Over to the right, serial monitor. Look at that. B is still 0. That is the nature of a local variable. We give it a value. That value starts out as 0. We print it. The value is still 0. We add 1 to it, but then before we get around to the beginning of loop and another print statement, we hit a closing brace. And that closing brace ends the life of B because it closes the starting brace it contained in. And when it starts over, B no longer exists, and B starts out brand new, shiny, and fresh, and 0. And we are never able to maintain with a permanent value that counts up one each time. That is different for A. A is now up to 210, and it retains its value every time we print it. Okay, so that's a global variable. Let's go look at the components of this program in a little bit more detail. They're kind of interesting. Okay, so serial begin, 9600. What's this command doing in more detail? It is telling both the Arduino and the host laptop that it wants to send data symbols, really, back and forth at 9600 per second. Pick that number. That's a funny number because that turns out to be the rate at which old-fashioned telephone data communications, that was the fastest speed it could run at. And then it jumped up above that, but for a long time that was the limit. So it's become kind of a magic default. Okay, now I said data symbols. A data symbol includes both the bits of our information, but when we're sending this information, it travels along in blocks. And between the blocks are things like little bits that say start and little bits that say stop and little bits that are error correcting bits, and all of these add to the total number of bits that get sent back and forth. So there are a few more data bits than there actually are information bits, if you want. And so 9600 baud is roughly bits, but it's a little bit higher than the real bit rate. What is it sort of in terms of printing? I don't know, it's a page a second or something of that sort. Pretty slow. You wouldn't send graphics of any sort over a 9600 baud line. You'd send it at one running at 115,000 baud or a million baud, even better. Okay, so serial is an object, and it really, with a capital S, contains all the information needed to communicate between the Arduino and the host. The only thing it doesn't know is how fast. So begin is called a method. It's a function like digital write and delay, but it's buried inside serial. To get at it, we say .begin, and then we give it the information just like it was a function, 9600. And that imports that data into serial, which is sitting off there somewhere all by itself with all kinds of information in it. And we've added 9600. Okay, going down to the bottom, we call the serial in loop here serial, and there are two versions of serial print. There's print and println. They look at the value that they're given, either the variable A, the space string, or the variable B. They figure out what it is, and they send that information at 9600 baud back to the laptop, where if we choose to look at it, we can open the serial monitor window. If we don't want to look at it, it just disappears into smoke. It does, however, slow your program down a bit, even without the delay. So after you're through doing your debugging and unnecessary printing, comment these things all out so that your program runs at full speed like that. Okay, and of course, take out the delay too. So that's what I would run if I wanted to run my program at full speed. All right, subject number 3. Let's see, we don't really need, yeah, I guess we do need serial print A. Let's put it back. Serial print space. Let's put it back. Serial print line. Let's put it back. And delay 200. Let's put it back. Okay, over on the left, I'm going to scroll up now to strings, number 10. So far, we've used integers. I think we may have used floats in some of our examples at school, but we haven't looked at strings yet. Strings are another type of data which are used for alphabetic characters, alphabetic strings. And they're coded inside using a code called ASCII, A-S-C-I-I. They're just binary numbers underneath, but they're interpreted specially by print and display devices as characters and graphics. And so over here on point 11, A in binary is a 0, 1, bunch of zeros and a 1, which if you looked at it as a number is 65 in decimal, the printer doesn't look at it as a 65. It gets 65 and says, oh, I'm a printer. 65 means print out the character A, which turns on little pixels on and off, okay? And just for fun, if I wanted to print out a 65, I'd have to send an ASCII 6 followed by an ASCII 5, and that's the following sets of 8-bit numbers. And if I concatenated those all together and asked what the value was, it's 13,877. And there's no relationship between ASCII and the values that it stands for. Okay, how do we make strings? Well, one way to make them, obviously, is just to type them where we want them used, like serial print over here on the right. But another way is we can declare them. So I'm going to go declare two strings. I'm going to put them down here below serial begin. I can do that. I don't have to put them up at the top. All I need to do is make sure they're outside of any curly braces. And there's two sorts of strings. One's called a C string, and one we might call a C++ string. They're typed the same, but they've got somewhat different properties, and they don't mix well. The only reason I'm going to show you both of them is because you will see both of them in code, and you need to understand what's going on. So if we look over here on 11, under declaring strings, declarations, I have two declarations down here, one of which is char, open close brackets. I'm going to just copy this and paste it and not bother to type it in. And I'm going to come back over here and paste it. Char brackets string S1 equals Bruce Hubbard in C. It says it's a C string. Okay. Then I go back over here to the left. I'm going to copy this and I'm going to paste it because this is getting to be kind of a long video. Copy. I'm going to go back over here. New line. Type it in. Okay. So string 1, string 2. Bruce Hubbard in C is the top one. Char bracket, or you will also see char asterisk, is another way to write this. Won't go into what that means, but it means it's a pointer or an array. And we'll go back to char bracket. And string S2, Bruce Hubbard, that's a C++ string. Okay, let's print these things out. So I'm going to go down here to the bottom. I'm going to get rid of A, and I'm going to print out capital S1. Then I'm going to put a space, leave it there. I'm going to print out capital S2. So now I'm printing out string 1 and string 2. All right, I'm going to leave the A's and the B's and the delays and everything else alone. All I've done is change the printing. Let's do a test compile. Error compiling. What did it say? Function void. S1 was not declared in this scope. Well, still not happy. I think we will probably call this done at this point. Error stray slash in the program. And of course, it doesn't care to tell me where that stray slash was located. Let me look real fast and see in the various comments that were added if I can spot a stray slash. And I am not spotting a stray slash. Let me take this line out. There's still a stray slash, so that didn't find it and fix it. Let me look more carefully at all the code we've touched and commented, the serials, the delays. We left the comment in. String S1 equals Bruce Hubbard in C ## semicolon, 2 slashes. String S2 equals Bruce Hubbard in C++, open close quote, semicolon, double slash slash. I'm not finding the bug at the moment, so I will look for it and we will resume this in a minute.